Okay, so this is nth roots and rational exponents. Like I said, our quiz is probably on the 17th, and our test is on the 28th, which is the Monday after Thanksgiving. So these are things that we kind of already know, right? 5 squared equals 25. Negative 5 squared equals 25. So when we say the square root of 25, you can get 5 or negative 5. Right? The square root of negative 25, we know we could simplify that now. With what we've learned already about complex numbers, we can turn that into 5i, right? Plus or minus 5i. But in this unit, in the book, when they get to that, they're just going to say that's non-real, right? We're generally not interested in that becoming an imaginary number. We're just going to say it's non-real. We're looking for the real number solutions here. For the most part, like if it's in the textbook, that's the way you'll see it. If it's in like one of my tests, that's the way you're going to see it. I definitely, where I used to teach, and I think maybe last year they kind of mixed and threw in a problem where they ended up using I as part of the solution, and that's not what we're used to, right? Those are a test I don't control. The SOL would never ask you to do that, right? That's really not the right way to go. We don't take the square root of negative 25. Okay, now, 3 to the third is 27. Okay, negative 3 to the third is negative 27, right? It's not like it was when you were squaring things, right? When we squared negative, what did we just do? 5 and negative 5, we got positive in either case. If you take a positive number to an odd power, you get a positive number. If you take a negative number to an odd power, you get a negative number, which means the third root of 27 is 3. The third root of negative 27 is negative 3. You don't say it's non-real because it is. It is a real number. It's just a negative number. So we don't have the same kind of thing going on. Okay. And one more. No, I went backwards. So when we write radicals, right, there's the radical symbol itself. The number, like when we take the third root, we put the little 3 there, that's called the index. And we do use that word. You have to know what it means. Whatever is the argument of the radical, which is the number inside, that's called a radicand. Now, when we were doing, and a couple slides back, when we did the square root of 25, you didn't see an index. So what's the index? It's a 2. It's there. It's just implied. If you don't see something written, the index is a 2. Okay. There is an index. It's just not there. You don't see it. So do one more for just the pattern. I don't like that one. 2 to the fourth is 16, but negative 2 to the fourth is also 16. So we would say that the fourth root of 16 is both 2 and negative 2. And again, because it's an even root of a negative number, we're just going to say it's non-real. We can't get that. So I'm going to skip the next slide because it had a mistake on it. But this is the summary of all that. Okay? The nth root of a, right? The even root of a positive number is plus or minus. 2 answers. The even root of a negative number is non-real. The odd root of a positive number is positive, and the odd root of a negative number is negative. Okay, next. Okay, so now here's where it gets more complicated. Okay, we know that like the square root of 2 times the square root of 2 is 2, right? Square root of 3 times the square root of 3 is 3. So we could say the square root of a times the square root of a. I mean, it's really, if we use the product property, right, we would say that the square root of a times the square root of a is the square root of a squared. But the square root of a square is just the number inside a. Okay, but now look at properties of exponents, right? I mean, if I didn't know what this was going to be, right? If I just said what's a to the x times a to the x equals a, what is x? Well, x would have to be a half, right? If there's something you're raising a to, a power that you're raising a to, that when you add that to itself, right? Because we know properties of exponents say that you add those up, and a half plus a half equals 1. So in fact, saying something, the square root using the radical symbol is the same thing as saying a to the 1/2. Right? That's using a rational exponent to say the same thing. It's still a radical, it's just in a different form. So if you go back to the first slide that had the objectives, this is one of the objectives. We're supposed to be able to like convert from radical form to rational exponent form. And that's what they mean by rational exponent. Again, what is a rational exponent? An exponent which is a fraction. Okay, now if you did if you take cube roots, right? The cubed root of a times the cubed root of a times the cubed root of a would be the cubed root of a to the third. You could like put them all under one radical. But the cubed root of a to the third is just a. Right, since you multiplied it together 3 times. Okay, well, with rational exponents, that means a to the 1/3 times a to the 1/3 times a to the 1/3. Because when you add them all up, what do you get? 1/3 plus 1/3 plus 1/3 is 1. So actually the cubed root of a is the same thing as a to the 1/3. Right, just another way to write a radical. Okay, so in general, the nth root of a equals a to the 1/n. You know, what would happen if I raised both sides, a to the n, the nth root of a, and I raised that to the m power? That would give me a to the 1/n, in parentheses, raised to the m power. Right? It's algebra. As long as I do something to one side, I can do it to the other. How do I simplify when I raise a power to a power? Properties of exponents wise. You multiply. Okay, what's 1/n times m? It's m/n. So that leads to this. If you have a to the m/n, that's the same thing as the nth root, a radical, the nth root of a to the m. I mean, that's literally saying, this is like saying, what am I thinking? A to the m to the 1/n. Right, this is the one we did like on the last slide. This is a to the 1 over n to the m. And in either case, you know, when you multiply m times 1 over n, you get m over n, and that's this right here. So the thing to keep in mind is, when you're using the rational exponents, the denominator of that fraction is the index of the radical, right? It's, in either case, that's the index of the radical. Now, the numerator of that fraction, it's somewhere, right? It's either inside the radical, like this one is inside, or it's outside. It doesn't matter which one, because in the end, you know, properties of exponents is going to make it m over n. But always remember, the index is the denominator. When you've got to convert from one to the other, index is denominator. Denominator equals index. Okay, so I think now we've got some simplifying to do. Right, evaluate, and this is without a calculator. 16 to the 3/2. So at this point, since we're not really comfortable using these rational exponents, let's convert 16 to the 3/2 to a radical, right? So 16 to the 3/2. What's going to be the index of that radical? It's going to be a 2, which means don't put anything there because we assume it's a 2, right? Now, you could either do this, right? You could say 16 to the 3rd inside the radical, or you could say it's the square root of 16 and then take that to the 3rd, right? Either one of those, same thing. Which one do you think would be easiest? The square root of 16 cubed. So what is 16 cubed off the top of your head? Anybody? Nobody knows that, right? Okay, try the one on the right. What's the square root of 16? 4. You know that, right? And now what's 4 to the 3rd? 64, right? So that is 4 to the 3rd, which is 64. You know, you probably find it easier to do that, to do it like the second way first. Okay, now, you guys are pretty good at this. You will be. You're probably not going to convert these to radicals every time you want to simplify them. What you're going to do is you're going to look at this fraction right here. And then, because you know that the 2 in the denominator, that's the index, just as you look at it, just say, what's the square root of 16? 4. What's 4 to the 3rd? 64. Done. I mean, without converting it to a radical, you just use the fraction. You know, use the denominator first, then use the numerator. Right? How about this 32 to the negative 3/5? Well, you might be saying, well, what are you going to do about the negative? Well, how do we get rid of negatives? Properties of exponents. You flip it to the other side of the fraction, right? So this should be 1 over 32 to the positive 3/5. Okay? And again, you can rewrite it as a radical, if that helps. Probably you'd want to do it like this. 1 over the 5th root of 32 cubed. Because what's the 5th root of 32? 2. 2 to the 5th is 32. So the 5th root of 32 is 2. In a minute, I'll show you how to do these things in the calculator. But so that's 1 over 2 to the 3rd. And 2 to the 3rd is 8. So it's 1/8. Again, you could just at this point, you probably want to take that step where you flipped it to the denominator because of the negative exponent. But then at that point, just say, okay, what's the 5th root of 32? And you should recognize the powers of 2 up to a certain point. Is 2, and then 2 to the 3rd is 8, 1/8, done. Okay, try, think this is your U try. So try those. So, everybody get that? Right? 4 to the 5 halves. Again, if you don't have to show that line of turning it into a radical, if you just think like a radical, right? Use the denominator. The square root of 4 is 2. 2 to the 5th is 32. Okay, 1 over 9 to the 1/2, that's the square root of 9, so 1/3. 81, the 4th root of 81, again, that's in our list right there. The 4th root of 81 is 3, and 3 to the 3rd is 27. And then 1 to any power is 1. So, what about 1 to the 0? It's still 1, right? Anything to the 0 is 1. Trick question. Okay, now we're going to do it in the calculator. So note, let's make sure you at least know how to use your calculator to do these things. Okay. Okay, how do you raise to the 1/5 power? Second quick. Right, how do you raise something to something other than squared? Yeah, you use the caret, right? 9 hat. Now, when you do that 9 hat, there's some calculators in here, and I haven't been able to figure it out yet, that are not throwing things into the exponent. Does anybody have a calculator that's not throwing you into the exponent? You see how mine, it's definitely above and to the right? I mean, we want the calculators to do that for you. Okay, now you're going to put in 1/5. And you don't have to use fraction format, but you could. Do you remember where the fraction format is in the calculator? Alpha y equals 1. Right? Watch. Alpha y equals 1. And now you can enter fractions so that they look like fractions. That will become important. But for now, it won't make a lot of difference in this problem. 1, 5. So we got 1.55, 178. Let me do it like this. Saves me from scribbling. There we go. Okay, try the 12 to the 3/8. $2.539. What's that?
Like the all you write is just the decimal.
Yeah, that's the answer. So let me copy that. And so that goes here. Now the last one is actually written like a radical. You know, you may find it easier to actually turn that into a rational exponent because it's so easy to use rational exponents in the calculator. What would be the exponent if you turn that into? It would have been 3/4, right? So you might find it easier to go like this, 7 to the 3/4. But just so we know, how would you take, as a radical, the 4th root of 7 in the calculator? Somebody just said it. It's the math menu, right? Look on the left where it says math. If you hit that right there, the number 4 option is the cubed root. The number 5 option is the x root, which means you can put whatever you want for x. Right? If I just say math 5 and it says answer, which we don't want, so just scroll over it and put in 4. And then go back inside to get a 7. Now remember, if you're inside the radical in the calculator, you need to know, like, if you're done with what goes inside, you have to right arrow to get out of the radical. Okay, it wouldn't make a difference on this problem, but it does make a difference sometimes. So that's the 4th root of 7. Honestly, usually the way you do that is first you hit 4, like this, right? Go 4, and then go math 5. And then it automatically puts the 4 in that position. So whatever is the index, type that, and then go math 5, and that's your index. But I mean, I didn't mean to do that, but you could even do math 4, right? Just do the cubed root, math 4, and then scroll over the 3 and make it a 4, okay? And now you're still taking the 4th root of 7. Done. So in that case, it is... What's that? I can't hear you. Yeah, we still have to do... Oh, that's right. You're right. I'm wrong. So we weren't done. That just gave us the 4th root of 7, and then we have to do what? We have to raise it to the 3rd power. And if you're not familiar with the calculator, right, I just said raise to the 3rd power. When it says ANS for answer, it's just saying that's the last thing you got when you hit enter on the calculator. And that is what we want, that 1.62 raised to the 3rd power. Bingo. 4.03, etc., etc. So let me snip that. Edit, copy, edit, and then, okay, so now you try those. Check your work. Check my work. And notice the 2nd and 3rd, you didn't really need the calculator because those actually were, 64 is a cube. So just take the cubed root, that's 4, and then square it. And then it's 1 over because it's got a negative exponent. How about did everybody have an, yeah?
What the last one?
Wait.
Why isn't it negative?
Well, how did you put that in your calculator? Did you put it in like this? Negative 30 to the 2/3?
No, I put it in as 3 and then square root negative 30 squared.
Say it again now.
3 like square the math button.
So, if you, it's kind of like an order of operations thing. So you take the cube root of negative 30, do you get a positive or negative? The cube root of negative is a negative, right? And then you square it, and you should get a positive. So, what you did is, yeah, she put inside the parentheses like this. Oops, don't do that. She put the cubed root of negative 30 squared. So, in that case, it squared the 30 to give you 900, but then it had the negative in front. So then it was negative 900, and then it took the cubed root of a negative 900, which would be a negative. But that's not correct, because it's actually the cubed root of negative 30 first, which is a negative, and then you square it, and it's a positive. So it's like if you wanted to do it that way, you needed to have like negative 30 in parentheses. Then you would have gotten the positive. Okay. What if it was a different? I got paper towels over there. If you need paper towels. Okay. The what if this problem, and it wasn't, but what if that problem instead was, what if you tried to go like this, negative 30 to the 3 halves? Try that in your calculator. Okay, so it says non-real. What does that sound like? I know, but when did we come across that today? You were trying to take the square root of a negative, right? So note, because we're raising it to the 3 halves power, and the 2 in the denominator is the index. So that's like saying taking the square root of a negative number, and that's what you're not allowed to do. So you got to be careful sometimes. If you've got even numbers in the denominator, that's an even root. So be careful about that. Okay, next. So now we can get to solving equations. Now we're going to do a lot more with solving equations on the 4th lesson in this unit. But for right now, we're going to treat this kind of like we did solving quadratics by taking square roots. If you remember, if you had something like 4x squared equals 64, then the strategy was to isolate the squared, right, and then take the square root of both sides. Well, here we're going to do the same thing. We're going to isolate the x to the 5th, and then take the 5th root of both sides. Right? So divide by 4, right? That's an isolate. Now we have x to the 5th equals 32. There's that number again, right? So now how do we turn an x to the 5th into an x? Take the 5th root of it, right? So we'll go the 5th root of x to the 5th equals x. And that has to equal the 5th root of 32, which is 2. Right? We've seen that. So it's like 3 times it's come up so far. But like I say, there's just not that many numbers they can deal with. If the intent is to make it something that, doesn't turn into a decimal, they got to use these numbers over and over again. Okay, so try. Oh no, this is one for me to solve. Okay, so the first step would be to isolate what's being raised to the 4th power, and it's already isolated. How do I undo raising something to the 4th power? Take the 4th root of both sides, right? The 4th root of something to the 4th, those are inverse operations. So the 4th root of x minus 3 to the 4th equals the 4th root of 21. Okay, so that means x minus 3 equals, and 21 is not a perfect power of 4 of anything. But remember, when you take square roots or 4th roots or any even root, you need a plus or minus. Right? So we have to say that's plus or minus the 4th root of 21. Okay, now we still haven't finished because we haven't isolated the x on the left. So add 3. X equals 3 plus or minus the 4th root of 21. Okay. So I think I've got 2 more U tries and then we're done. Solve. All right, so first you had to isolate, multiply both sides by 2, and then take the 5th root of both sides. It should have been 4. Right, we went up to 4 to the 4th on the board there, 256, and you do 4 more, times 4 one more time, 1024. Okay, last one. try to solve. Right, so when you take the even root, you need a plus or minus. Okay, and that's plus or minus 2. When you subtract 5, that's negative 5 plus or minus 2, but then you can simplify that, right? There's no reason to leave it in that form. Negative 5 plus 2 is negative 3. Negative 5 minus 2 is negative 7. That's it.